This is a Chapter 8 lesson, but I am going to pre-teach this week. Actually, I'm probably going to be pre-teaching for the next 3 weeks, all the way up into the test. What I mean by pre-teaching is that there is a topic coming up after this test, after this chapter, or after what we're dealing with right now, and that topic is a big challenge. So what we're going to do slowly is just kind of look at ideas of what goes into that so you can kind of have some of those things down. I do recommend that you take notes and that you ask questions about whatever is going on here, because it's really not hard to do, but if you don't have this skill by the time we get to where that chapter starts, then there's going to be an issue again. To find factors of a number, we just use division. Factors themselves are numbers that just divide evenly into a number. So what we would do, and again, you can hope you're not stubborn, but the best way to do this is the way that I am doing this here. And so add this to your skill set. I would even say write it in your notes so you can kind of go along with it, and then as we go through the week, whenever you see this, go ahead and try to make the factor list for yourself and see what happens from there. So what you do to do the factors of 60 is you start from the number 1, because you want an organized list of factors. We're going to need those organized for a reason. Is you start with the number 1 and say 1 times what makes 60? Of course it is 1 times 60. Then move to 2. 2 times what makes 60? That would be 2 times 30. If you don't know what it is, just do 60 divided by 2, which tells you it's 30. 3, checking 3, 60 divided by 3 gives me 20. And notice all we do is just keep that pattern. Now we do 60 divided by 4, which is 15. Then we do 60 divided by 5. Again, we just keep going up the list. 5 times 12. So again, 60 divided by 5 is 12. 60 divided by 6 is 10. 60 divided by 7. Now this is what we've been waiting on. If you get a decimal, it means that this number is not a factor of 60, which means we don't even add it to the list. So now we do 60 divided by 8 because we got a decimal for 7. The fact that we get a decimal for 8 means that this is also not a factor of 60. 8 is not a factor of 60, so we don't write it. 60 divided by 9 gives me a decimal. We don't write it. 60 divided by 10 gives me the answer of 6. Well, here's the thing. When the answer that you have, which actually we could have done this a while ago, but when the answer that you have is bigger or smaller than the answer that you plugged in, it means that we have already repeated. Again, notice that the 10 is here, 6 is here. That is our stopping point. Finding the factors of 60 is that simple. Again, please make sure you ask your teacher or bring up the page to me if you are in class with me at this time to ask about how that works. But again, that would be factors of 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Again, make sure you don't have to be perfect at it yet, because we are going to be doing that one skill all week, but just kind of add that to what you understand and what you know, and we'll revisit it again tomorrow. For now, we're moving on to chapter 8.1. This lesson is a nice, easy way to start the second quarter. There are 3 main parts to this information. Luckily, 2 of them should already be within your range of algebra experience. We're going to start with the one thing that you have not seen just yet, and then move on to the rest of the day's work. Before we do that, jot down these 3 vocabulary terms, which is monomial, polynomial, and degree. Monomial is any single term. 3x is a monomial. Negative 8 is a monomial. 5x squared y is also a monomial, because each of these represents one single term. Polynomial is one or more monomials combined into an expression. Notice how I took each of these monomials and I made a polynomial by simply combining them into one big piece. So again, a polynomial is where you have one. Each of these things is also called a polynomial. But again, a true polynomial is whenever you have a bunch of things put together, or even just 2 things put together with pluses and minus signs into one expression. Degree is the number of variables attached in a term, which we're going to talk about first, because that is the one thing that you have not seen. As you should have written in your vocabulary, the degree is the number of variables attached in a term. Finding the degree of a monomial is as simple as counting. Let's do the degree of some monomials real fast. And again, this is very simple to do. Don't overthink it. Just keep in mind, degree is the number of variables attached. So in this term, don't worry about the coefficient. That's not even really important. What you are doing here is you are saying I have 3 x's and 2 y's. And as you learned in chapter 7, 3 x's, 2 y's make 5 total variables attached in this term here, which means that the degree of this one term is 5. That's it. Again, ignore this number because that has nothing to do with it. You're looking at how many variables are attached. It says x to the 6, which means that there are 6 x's attached in that term, which makes the degree 6. Here, again, ignore the coefficient. It has nothing to do with anything. Here we have 7 m's, and don't forget when there's no number, it represents 1 n, which means that there are 8 variables attached. There are 7 of these, 1 of those, making the degree of this term 8. And then once again, we ignore the number, but notice that there is nothing attached to it, which means the degree of this one is 0. Alright, so again, when you're asked to find the degree later, 3 and 2 make 5 things here. There are 6 variables attached here. 7 plus 1 makes 8. No variables attached there, which makes a degree of 0. Find the degree of a polynomial, which means more than one term again, is also simple. In order to get it done, we just first identify the degree of each term, and then we choose the highest of the degrees to represent the polynomial. So real fast, here's what we're going to do is look at 2 of these. What you do is you look at this one first, and you say to yourself, what is the degree of this term? Well, there's 1x attached, which means the degree of this one term is 5 or is 1. Then you look at your next term. Again, ignore that part. Here we have 2y's attached, which makes the degree of this one 2. Looking at this term, don't forget it's a negative 2. There are no variables attached. That means the degree of this one is 0. And then looking at this term, you recognize that there are 2 x's, 3 y's, making the degree 5. And again, all you have to do is pick the biggest number. Do not add them. Do not do anything else, but recognize the highest number. Overall, the degree of this would be 5. Again, if you're looking for the degree of a group of terms, simply pick the highest number to represent it. Alright? Again, looking at this, the degree of this one is 3 x's, 1 y. It's 4. The degree of this term is just 3 y's, so it's 3. The degree of this one is nothing attached, which means it's 0. The degree of this one is 4 x's attached, which is 4. And it does not matter if you have a tie. What you're looking for is the highest number, which in this case is 4. It means the degree of this whole thing is 4. Okay, so overall, simply count the number of variables for the degree in the monomial, or we simply choose the highest degree in the polynomial. And that is really all that is new in terms of what's going on. What the topic of this is adding polynomials. We're separating this into 2 days. We're going to deal with adding today, subtracting tomorrow. Adding polynomials is the same thing as combining like terms. Just remember from the first chapter of algebra what like terms are: 2 terms with the same type of variable attachment. 6x, 9x, negative 5x are all like terms because they have a x on them. 4x squared, negative 3x squared, and x squared are all like terms because they all have x squareds on them. Even in this case, 6, negative 8, and 4 are all like terms because they are all constants. In other words, they don't have any x's at all, so they are all similar in the fact that they don't have a variable attached. Recognizing like terms is only the first step, though. What you're going to need to do is develop a system of organizing your work. The best way to do this is to work with a system that puts your answers into what we call standard form. Standard form is written so that the powers go from highest to lowest. I will be using this system with the following example, so be sure to adopt it or try to adopt it into your work. It'll save you a lot of time if you just go ahead and start out this way and treat it as if it is the only way to do it, even though it's not, because in that way you don't have to worry about shifting things around whenever you get into classes or problems where they want the answer in standard form. But again, what I'm going to do is standard form in terms of combining like terms when necessary. You're going to see problems that look like this: 9f squared minus 7f plus 3 plus 2f squared minus 2f minus 5. And again, all we have to do is add up each term. These two things, 9f squared, 2f squared, make 11f squared. Remember, do not change the term or the label on the term, just like when we combined like terms before. If it's f squared, it stays f squared. Negative 7f, negative 2f. I know a lot of you are not great with numbers, so my suggestion for you is, as long as you're allowed to use the calculator, just type in the first number, and then the second number would be minus 2, which gives me a negative 9, so you get negative 9f. 3 minus 5 Again, if you have issues with that, 3 minus 5 gives me the answer of -2, which is what goes here. Why is this in standard form? Because the highest power is 2, then 1, then 0. Alright, so again, this is already in standard form because the problem was given to me in standard form. There was nothing to worry about. Now, in terms of this question here, 5x to the fourth minus 3x squared plus 4 plus -x to the third plus 8x squared. What you do whenever this is a plus sign, it means that you're just going to put the two things together. This is what we're learning today. What I do is I look for the highest power, x to the fourth, and I ask myself, are there any more x to the fourth that can be put together? No, there are not. And so I bring down 5x to the fourth. Next number for 4 is 3, or from 4 is 3. I see one right here, and notice how I underline it differently. X to the third is here, but there are no other x to the thirds, and it's a -x to the third, which means I have to respect it by bringing down the -x to the third. Pluses and minuses, if you remember, are like the Mr. or Mrs. in someone's name. Don't call someone Mr. Bradley if their name is really Mrs. Bradley, or whatever it might be. So you have to respect the fact that that x is negative, otherwise you are disrespecting that number itself. The next number past 3 is x squared, and again I'll underline that differently, and I would start to try to use that whenever you combine your terms. But I have an x squared here, and as you look, we also have an x squared there, and this is where your combining like terms comes in. -3, +8. If you're no good at that, just type it in, -3 and +8, make 5, which is positive, so we will put plus 5 x squared. And the last thing that is there is no variable whatsoever because there's no x's, so we simply bring down our plus 4. And again, notice standard form, 4, 3, 2, 0. That is your standard form that you are looking for. Alright, one more example before we move on to the lesson. Again, looking at this, start out with the highest. This is just a plus sign, which means it doesn't do anything. Just put everything together. P to the third has no other companion, so we bring it down. P squared, again I'll underline this twice. That's a p squared there and a p squared there. 2 here, 9 there, both of those are positive, which makes 11. Again, p squared. Here's a regular p and another regular p here, so -6, -5. If you don't know that already, just type it in, -6 minus 5, which makes -11. That is with a p. Another way you could type that in is to type each number -6 plus -5, and you still get the answer of -11. But just make sure you work on that. Again, if that's if you are a type of student that isn't good with numbers, then you better learn how to program your calculator. So it's a skill you're going to have to work on your own, not something that it's our responsibility to make sure you know how to do. And the last thing is -11 has nothing to go with, so it just comes on down. Alright. So before moving on to your lesson, take a moment to answer the following question. Afterwards, bring it up to me for quick feedback or to your teacher for quick feedback. What this is going to let you do is see what your mistakes are before moving on to today's work. What you don't want to do is start working, make 20 mistakes, and then find out that one thing was really causing you a bunch of issues. So be sure to try your best to master this material, because tomorrow we move on to something else. And again, we understand that you won't be perfect after today, but if you don't try to get as good as you can, then you're going to probably have issues tomorrow when we move on to subtraction. Ask questions and work hard. Again, the second quarter starts today, and it is best to start out the right way, as some of you probably learned on Friday, or some of you learned today, as you see that you're probably not passing because you did not start out well and couldn't get out of the hole that you dug. So I suggest that you go ahead and start the right way. That way everything ends a little better for you maybe this time and gives you a shot at passing for the semester. Other than that, work out this question, bring it up, and again, that is your credit for me. Not sure about your other teachers, but like I said, it is definitely your credit for me. Good luck.